So in last class, we have just discussed all about the Born approximation. And you all know that how we can use this particular approximation. And we have done for the low energy as well as for the high energy. So let us try to discuss partial wave analysis. And mainly we will discuss the phase shift. Actually, we have to work on two different formula. So ये दोनों फॉर्मूले के ऊपर हम वर्कआउट करते हैं और फिर देखते हैं कि ये दोनों फॉर्मूला को किस तरह से आप डिराइव कर सकते हो. Actually, not exactly derivation, but we will do this derivation with the help of analogy. So let us try to go for the actual discussion of scattering. So let's try to go for this. So what we have, we are just going to divide the whole thing into three regions. So this is region 1, region 2, and this is your region 3. This region is very importantly known as radiation zone. And this region is popularly known as what? Scattering zone. So do you identify what is a scattering zone? That where you have the influence of potential. And this is all about the intermediate zone. Intermediate zone. So here we have potential is equal to 0. And in this particular zone also, the potential is 0 as well as, and this is very high value of R. So this is very, very big R. We are just talking about the big R. That means when we are talking about the scattering, so if you are going for the schematic diagram, we are talking about in this region. This is basically this part, okay? And this is near about between these two things. So what we have to do, the basically potential is spherical symmetric potential. So L square is going to commute with Hamiltonian. Yes. So YLM theta phi is a solution of this particular Hamiltonian. YLM theta phi is solution. And we have to only worried about the radial part of solution. Okay. So let's try to go for radiation zone. First, we are just going to go for radiation zone. What will be the solution? And obviously we have to solve the radial part by putting R is equal to UR by R. So ये सारा हम लोगों ने कर रखा है हाइड्रोजन एटम में. Everyone is comfortable? है ना?
Yes.
And what is your equation? Your equation is basically d square u upon dr square, and you have minus h cut square also, and 2m is the mass of particle, plus we have centrifugal term L into L plus 1 h cut square upon 2m r square plus potential energy Vr. Ur is equal to what? EUR. If we are able to solve this equation, then everything is good for us, but it will depends on potential. We have seen that when potential is Coulomb potential, you can see in hydrogen atom how much difficult it was to solve. याद है सारा story in hydrogen atom?
Yes, sir.
So it is very difficult to solve the thing. But yes, we will play some trick. And what is this trick? First, we are just going for the case 1 for the radiation zone. And this range is very small. This range is very small. Okay. In the radiation zone, R is very large. So centrifugal force or centrifugal term is not so relevant. And this potential is also assumed to be 0 because it has very sharply decreasing at R tends to infinity. So what will happen? We have actually minus h cut square upon 2m d square u upon dr square. So this whole term is 0, must be equal to what? EUR. Yes. And what is your solution? Your solution is UR is equal to e to the power IKR. We are talking about after scattering. So minus sign is not relevant. We are just taking the plus sign. So this is coming and it is going into this direction. So this is my plus sign. Everyone is comfortable? And
Yes.
when you are going for the radial part, then radial part is e to the power IKR by R. And what is value of K? The value of K is nothing but 2m
by x
E
square.
upon h cut square. So this thing is very interestingly solvable. Good, great. Now we will go for intermediate part. At some level of this particular thing, we can also solve the intermediate part. So when we are going to solve the intermediate part, what is difference between this radiation part and the intermediate part is that only potential energy is assumed to be 0, but centrifugal part is there. यहाँ पर centrifugal part है और वो यूज कर रहा है. ठीक है? So let's try to go for this. So when you have this particular thing, minus h cut square upon 2m d square u upon dr square plus L into L plus 1 h cut square upon 2m r square ur is equal to er. And this is very famous differential equation, and the solution of this differential equation is basically a spherical Bessel's function. क्या solution होगा ये? Spherical Bessel's function, and we can just go for the solution, and that solution is UR is equal to, you can write AL, some coefficient AL, and this value is equal to R JL KR plus BL R, and you have NL KR. Okay, so these two thing is there, and if you are just analogically try to understand this thing, then this thing is something like sine and this thing is something like cos. Are you getting my point? एक sine की तरह function होगा और दूसरा किसकी तरह function होगा? They will be just behaving like as a cos function. Okay, so this type of solution is always there. Okay, so now let's try to go for this particular thing. And it is very difficult to solve the equation here. It is very difficult to solve this particular equation. And this JL and NL can be written in a form of Hankel's function. Don't scared. This is HL1. There are two type of Hankel function. This is HL1 and there is what? HL2 type Hankel function. What is this thing? Hankel functions are basically some form of e to the power I kx by x type of function. Are you getting my point? So hence this can be written as sine or this can be written as cos, then it can be written as e to the power I kr and e to the power minus I kr के फॉर्म में लिख सकते हैं ना?
Yes, sir.
Yes. And what is beautiful part of Hankel function, that at the very large value of r, this will be something e to the power I kr by kr sort of function. So this is the solution at the very large value of r. Now, look at which type of, so when we are try to solve this and when we are trying to solve this two thing, and we have the actual solution as, हमारे पास जो actual solution है, what is this particular actual solution, जिसे हमें analogically हमने कहा है, that solution is basically psi r theta phi is some constant a e to the power I kz plus f theta e to the power I kr by r. This is our general solution of our scattering, and this is your something you can say this is coming from the z axis. It is just propagating the plane wave along z axis. But and this is your spherical wave after the scattering, and this is form factor. So when we are going to solve this particular thing, and when we try to write the final solution, so the final solution is something like this one. So the final solution is a e to the power I kz plus k time summation over I to the power L plus 1, 2L plus 1, HL1 and PL cos theta. And sorry, there is one more term is there, which is basically, let me write this thing. That is AL, and that value is equal to HL1 KR, and that value into PL cos theta. AL is some unknown quantity itself. This is some unknown quantity. ये दिखाई दे रहा है आपको? है ना? So this is your AL. This is your amplitude term. This is your sum function. And why PL cos theta is there? Because this is a spherical symmetric system, तो वो हमेशा रहेगा ही रहेगा. Are you getting my point? ये सारे चीज कहाँ से आ रहे हैं? We are not bothered. We are just using this particular thing. ठीक है? Obviously, this is due to degeneracy. For given value of L, there are 2L plus 1 time this particular thing is time this PL cos theta can be there. L के लिए degeneracy क्या है? That is what? 2L plus 1. So this is your particular thing, particular equation. Now look at what is the idea. Still, we are not able to solve this particular problem. Why? Because we don't know what is this AL. AL is basically amplitude of the particular, you can say this is superposition of n number of waves, isn't it? कितने number of wave है? N number, all possible L के लिए ये superposition है. And A1, A2, A3, A4 are the basically identified as what? Amplitude part of what? Partial wave amplitude. So this is, and why it is partial wave? Because you have all possible thing. आप सारे possible चीज को एक साथ add कर रहे हो. You are taking the superposition. L is equal to 0, L is equal to 1, L is equal to 2. This kind of situation, you are just going to add on. So this is your AL. Now look at what is going to happen. This is very interesting. Now it is given that this HLKR is behaving like e to the power IKR upon KR when R is very big. So what we can do? We can compare these two things. इन दोनों चीज को हम compare कर सकते हैं ना?
Yes, sir.
Yes, we can compare it. So when we are going to compare it, then what is your F theta? F theta can be written as summation over I L plus 1, and this K is going to cancel out, isn't it? ये दोनों K cancel हो जाएगा. And we are just comparing e to the power I KR. So what is this particular thing? 2L plus 1 AL. लिख सकते हैं इसे? Yes or no?
Yes,
And also PL cos theta. Also PL cos theta. Now this is summation over L. Now I am interested into differential scattering cross section. मैं किसमें interested हूं? Differential scattering cross section. So what is differential scattering cross section? Mod. This is mod. Sorry, differential scattering cross section is what? F star theta and F theta. And this is nothing but the mod F theta. Now just tell me. We have to take the all possible value of L. When we are talking about the F star and F, then there will be single summation or double summation. Here is the catch. और इसी के ऊपर एक बार बहुत अच्छा प्रॉब्लम आया था. There is single summation or double summation?
double
Double summation. Why? Because you have to take
Yes, sir.
all the possible value of L, isn't it?
Yes, sir.
So
Yes.
we have to take the two different L, one is for star and another is for F. So what will be this value? We will just go for L1 and another we will go for L2, and this will be minus, so स्टार के लिए क्या आ जाएगा, माइनस आई टू द पावर एल प्लस वन, और नॉन स्टार के लिए आई टू द पावर एल प्लस वन, यही होगा ना, सॉरी
Yes, sir.
L1 plus 1, and this is what, L2
L.
plus 1. ठीक है, and what is this particular thing, 2L1 plus 1 and 2L2 plus 1. There is AL1 star, 1 के लिए मैंने स्टार लिया है, AL2, and here is PL1 cos theta and PL2 cos theta. So this is your differential scattering cross section. Are you getting my point? This is your differential scattering cross section. Don't worry. Clear है यहाँ तक, है ना? Now, so this is your differential scattering cross section, and this value will be just going to be 0. Sorry, ये दोनों एक दूसरे को एडजस्ट कर लेगा. क्यों एडजस्ट करेगा? ऑड होगा या इवन होगा, ये तो यही होगा ना.
Yes.
So
Yes,
that
sir.
value is more or less 1. Either एक बार माइनस के साथ एक बार प्लस के साथ है आई, so this value will be more or less, और हमें मॉड के लिए लेना है तो इसकी कोई खास वैल्यू वजह नहीं रहेगी, है ना. अगर -1 भी आएगा तो हमें प्लस लेना है, प्लस भी आएगा तो -1 लेना है. So there is, this has not any significant for this particular thing. Are you getting my point? क्या इसका कोई significant होगा क्या?
No, sir. Mod.
Either ये 1 होगा या -1 होगा या आई होगा, yes or no?
Yes, sir.
या माइनस आई होगा, यही तो कॉम्बिनेशन बन सकता है. So it has not any more significance into calculating the differential scattering cross section. So this is your basically the differential scattering cross section. Look at this, is very interesting, और इसके ऊपर एक बार बहुत ही बढ़िया क्वेश्चन आया था. So I will just give you to solve, है ना. Now you have to understand this particular indexing. So your differential scattering cross section d theta is nothing but the two summation L1 and L2. It's very interesting, nahi? 2L1 plus 1, 2L2 plus 1, and you have a L1 star, a L2, and you have PL1 cos theta and PL2 cos theta. Wow, awesome. Clear है ये? Now what will be your total scattering cross section? क्या होगा?
Into
d
2 pi sin
theta
theta.
sin theta d theta,
D.
isn't it?
2 pi.
Into 2 pi, exactly. That value is into 2 pi. So now when we are going for this particular term, then obviously this is going into integration and all other term will be coming outside, isn't it?
Yes, sir.
है ना? So look at this particular thing. Very interesting. So what you have actually summation, double summation, you have L1, L2, and we can just go for integration, and we have 2L1 plus 1, 2L2 plus 1, and here is AL1 star, AL2 star, PL1 cos theta, PL2 cos theta, sin theta, d theta. I can take 2 pi outside and I will keep my integration here. Can you please tell me what is this particular value? Very famous integration.
2 by 2L plus 1.
Very good. This is basically orthogonal relationship for the
Yes, sir.
legendary polynomial, isn't it?
Yes, sir. Yes, sir.
So what is this particular thing? This integration is actually when we can go for 2 pi summation over L1, summation over L2, 2L1 plus 1, 2L2 plus 1, A L1 star, A L2, and this is nothing but 2 by 2L plus 1 delta, or L1 plus 1 kar do, L1, L2. Isn't it? You remember this integration?
Yes, sir. Yes, sir.
Sutton, are you comfortable?
Yes, sir.
है ना? अब देखो इसका फायदा क्या होगा? इसका फायदा होगा कि ये L1 और L2 सिर्फ डायगोनल टर्म के लिए सर्वाइव करेंगे, अदरवाइज ऑल आर जीरो. Isn't it?
Yes, sir.
Diagonal means L1 is equal to L2. So what will happen? One thing will be cancelled out, and you have total scattering cross section is 2 pi. Now double summation will change into single summation. 1 2L plus 1 is going to cancel out, and you have mod AL square, and 2 will be also there. So 4 pi is there. Wonderful. So this is a particular very interesting equation for total scattering cross section. If somehow you are able to calculate AL, you can easily get total scattering cross section for summation over all possible value of 2L plus 1. Are people comfortable?
Yes, sir.
Okay. Now, how we are getting this particular AL? इस AL को हम कैसे निकालेंगे? ये एक बहुत बड़ा चैलेंज है. Okay. So now we will just try to find this AL in form of phase shift, and the method of phase shift is very interesting. So partial wave को हम लोग phase shift से connect करेंगे, and we will try to figure it out कि किस तरह से इसको calculate किया जा सकता है. So let's first go for one dimensional analogy. One dimensional analogy के through इसे हम समझने की कोशिश करते हैं. यहाँ तक clear है ना?
Yes, sir.
So अगर आपको एग्जाम में किसी तरह पार्शियल वेव एम्पलीट्यूड दे दे तो आप टोटल स्कैटरिंग निकाल सकते हो. यस? ओके. लेट्स ट्राई टू गो फॉर अ फर्स्ट वन डायमेंशनल एनालॉजी, and we will go for understanding of concept of phase shift. This is very interesting. अब देखो क्या हो रहा है, ये जरा हम देखने की कोशिश करते हैं. This is very interesting one. Suppose this is rigid wall, and we have some orbit potential here for short range potential. Let's say this is at A, and here V is equal to 0. So what is going to happen? I can throw my particle from here. It is free particle into this region, isn't it? It will
Yes,
come
sir.
here, collide with this wall, and again come here, isn't it?
Yes, sir.
And in this region, there will be something is going to change. What is going to change? Let's try to discuss. So in this region, what is my solution? A sin kx type of solution is there, isn't it? Why A sin kx type of solution there? Suppose this potential is 0, which may be possible. Suppose this potential is 0, then my wave function have to vanish at x is equal to 0. So my solution, the accepted solution is something A sin kx type of solution into this region. ये किस region में है solution ये? A sin kx into this particular region. Now, this is written, this can be written as e to the power I kx minus e to the power minus I kx by 2i. लिख सकते हैं इसे? Yes or no? Yes. So now, what is this particular thing? Hence, I am approaching my potential from left. This is my incoming wave. ये क्या है हमारा? इनकमिंग वेव. एंड व्हाट इज दिस थिंग? आउटगोइंग वेव.
Out.
आफ्टर जो वापस आ रहा है वेव इन दिस रीजन, ये दोनों मिलकर सुपर इम्पोज करके तो साइन देंगे, है ना?
Yes, sir.
So this will be something like outgoing. So what is this solution? Incoming plus outgoing, isn't it?
Yes, sir.
This is nothing but incoming plus outgoing. Okay. So now this is my solution into this region, Okay. And let us try to give the solution. Complete solution में हम ये देख रहे हैं that amplitude is not going to change because number of particle is just going to conserve. What is going to change? The incoming particle is also not going to change. Are you comfortable? Isn't it?
Yes, sir.
Because incoming particle is always incoming particle. What is going to change after scattering is outgoing particle, and here I can claim this change in outgoing wave function is something the change in a phase shift. You can take an analogy. So अगर आप किसी भी हार्ड वॉल से टकराते हो तो आपका फेज कितना का चेंज हो जाता है? पाई का चेंज हो जाता है ना?
Yes, sir. Pi.
पाई का चेंज होता है. So hence it is hard wall. Then we can have some phase change pi, and now we have some potential. So I can say these phase change are some arbitrary phase change. कैसा phase change है ये? Arbitrary phase change मिल रहा है. And that is the complete solution. The complete solution is incoming wave plus outgoing wave. So my complete solution is something like, I can claim my complete solution is psi, and which is amplitude is just remain same. The 2i part is also remain same. What is going to change? The change is e to the power ikx plus, you can multiply it, e to the power I 2 delta L x, 2 ik delta Lx. Okay. Sorry, 2i delta L. So this is your just a change in phase, and obviously this will be the solution, minus e to the power minus I kx. So this is the complete solution. So what is complete solution? The complete solution is the, now look at this particular figure. You can give me, you can just assume this figure. Okay. This is A, and here potential is 0. So we have solution in this region. So this is the solution, and this is complete solution. This is the overall solution for this particular region. So I can write this solution is equal to A sin kx plus scattering wave function. लिख सकते हैं इसे? Yes or no?
Yes, sir.
This is your complete solution. This complete solution will be solution into this region and solution into this region. Are you getting my point?
Yes, sir.
यही तो होगा. This is my complete solution. So now I can compare these two things in a very nice way. A 2i e to the power I, and just a minute, what is this? 2i delta, sorry, I kx plus 2i delta L minus e to the power minus I kx, and that value is equal to A upon 2i e to the power I kx minus e to the power minus I kx plus phi s. हो जाएगा ये? So this part is going to cancel out. ये part तो cancel हो जाएगा ना on both sides.
Yes, sir.
And I can subtract this thing into this region. इस region में मैं जब subtract कर रहा हूं, then what I will get? A upon 2i e to the power I kx, I can take common, and e to the power 2i delta L minus 1 is equal to scattering, Fs. Yes? And here we can write this whole thing as A by 2i e to the power I kx. And what is this thing? You can take e to the power I delta L common, e to the power I delta L minus e to the power minus I delta L pi s. So 2i will come here. So this will be what? Sine delta L?
Yes, sir. Send
Yes
me.
or no? Yes. So what is your phi s? Your scattered wave. Your scattered wave is basically A e to the power I kx, e to the power I delta L, and sine delta L. Everyone is comfortable here? Now
Yes,
this
sir.
is my one-dimensional analogy. This is my one-dimensional analogy. Now, look at very interesting thing. What is e to the power I kx?
Outgoing of it.
Outgoing wave. What is this particular thing?
Outgoing.
Outgoing wave. Okay. So this is nothing but outgoing wave. This is your outgoing wave. Yes. Now this is your outgoing wave. So what we have done, we have write our scattered wave or scattering wave function related to scattering. This is a scattered wave as a function of outgoing wave and phase shift, है ना? The phase delta L. इसके टर्म में हमने इसे लिखा है. Are you getting my point?
Yes, sir.
Now, let's try to use this analogy into three-dimensional system. अपने three-dimensional system में हम इसे use करते हैं. Okay? What is this particular thing?
Sir, e to the power I kr by r.
Very good. What is this particular thing? No. What is this particular thing? A scattered wave.
Scattered wave. Yes, sir.
What is this particular thing?
Sir, free region में जो wave है.
Incoming and outgoing.
Yes, sir. Okay.
Incoming and outgoing. Now, look at this analogy. Very interesting. So what is analogy? So psi is equal to A e to the power I kz plus phi scattered. यही तो है ना?
Yes.
ऐसा ही तो है? Yes या no? And this is A e to the power I kz plus phi s को हमने क्या लिखा था? F theta e to the power I kr upon r. Everyone is comfortable? So this is your scattering wave. This is your scattered wave. And this is which kind of wave is there? Just compared to here. यहां से कंपेयर कीजिए. क्या है ये?
Incoming wave.
ना. फिर से ये क्या है?
Incoming plus outgoing.
तो वो क्या होगा?
Sir, वो भी incoming plus outgoing.
Exactly. So when you will see the whole picture into 3 dimension, then this is nothing but incoming plus outgoing. ये आपको क्या मिल रहा है? This is nothing but what? Incoming as well as outgoing wave. Just a minute. Clear है ये? Now let us try to see what is going to happen. देखो क्या हो रहा है. And now what you can do, you can write e to the power I kz as e to the power I kr cos theta लिख सकते हैं ना in a spherical polar coordinate?
Yes, sir.
And you can write this whole thing as summation over JLKR and PL cos theta, and 2L plus 1 is also there. And you can write something like L. You can write this whole thing. कैसे लिखोगे? Just you will go for the Taylor expansion and you will collect all the term and you can have this particular thing. आप इसे लिख सकते हो. So what is this particular thing? Now forget the Z part. Forget the plane wave is coming. What is going to happen? Suppose this is your central potential. You can approach your potential from all the region. Are you getting my point? You are approaching it, interact it, and go there. Approaching it, interact it, and go there. Yes?
Yes.
And we have solution at this particular region. That is the complete solution. This is the complete solution. Yes? So what will be the final outcome? So when we will use this particular thing, and then we can go for this particular solution as अब इतना डेरिवेशन नहीं करेंगे तो आपको कुछ समझ में ही नहीं आएगा क्या कर रहे हैं एक्चुअली. So what will be this particular thing? So we can have psi r theta phi is something A, and here you have I to the power L, 2L plus 1, and we have JL KR plus I K AL, and what is AL? Partial wave amplitude. Remember this thing? और साथ में
Yes.
क्या था? HL1 and PL cos theta. Agreed? This is your complete solution at any. And when you have this type of solution? When you have this type of solution? When VR is equal to what? 0. This is your complete solution when VR is equal to 0. And we also know that this is e to the power I KR upon KR. Yes, when R tends to very big. So what is going to happen? What is your scattered wave? What is your scattered wave here? Phi S. क्या है scattered wave? बताइए.
Sir, e to the power I cube by r.
L cos theta.
K से K तो कैंसिल हो जाएगा.
Yes, sir.
ठीक
Sir,
है ना?
AL cos theta.
So what is this particular? AL e to the power I KR upon R. This is your scattered wave. Yes.
Yes, sir.
And PL is always there. So PL को मैं सिर्फ radial part को देख रहा हूं. And this is equivalent to, अभी हमने क्या निकाला था? What is your phi S from the partial wave? A will be also there. So A को तो आप रहने ही दो, साथ में रख लो. A और क्या था? E to the power I kx, e to the power I delta L and sin delta L. यही था ना?
Yes, sir.
Okay. So now A will be there. और e to the power I kx की जगह पर क्या आएगा?
E to the power I kr by r.
E to the power I kr by kr. ये आएगा ना?
Kr, yes. हाँ.
This will be thing. And e to the power I delta L sin delta L. Are you getting my point? So now from here you can have AL is equal to, क्या आ रहा है? 1 by K e to the power I delta L sin delta L. मिल रहा है हमें? And what is your total scattering cross section? The total scattering cross section is basically summation over 2L plus 1 and mod AL square. और यहाँ क्या था? 4 pi. Now you can change this particular AL. And what is this value? 4 पाई समेशन ओवर 2l प्लस 1, इसका मॉड लोगे तो क्या आ जाएगा 1 बाई के स्क्वायर, और यहाँ क्या हो जाएगा दिस विल बी ऑलवेज 1, so you have sine square delta L. This is your total scattering cross section. Yes, so you have to remember this particular formula. ये फॉर्मूला आपको क्या करना पड़ेगा, रिमेंबर करना पड़ेगा. Yes,
yes,
so अब एग्जाम में क्या दिया रहेगा, k का वैल्यू क्या है √2me अपॉन h cut square, and delta L they will give you delta L in some form. You have all possible value of L and you can easily calculate the thing. So let's try to solve some problem. कुछ प्रॉब्लम को डिस्कस करें, फिर आप इसे देख लोगे कि आपका कॉन्फिडेंस आ जाएगा, है ना. क्लियर है यहां तक?
yes sir.
ओके,
Yes, sir.
गुड.
सर एक मिनट सर,
बोलो.
रब मत कीजिए सर.
हाँ ठीक है, आप कॉपी कर लो. एंड दिस इज समेशन ओवर L, है ना. तो आपको सारा डेरिवेशन याद नहीं करना है, बट एटलीस्ट यू हैव टू रिमेंबर दिस एक्सप्रेशन. ठीक है,
yes sir, ठीक है सर.
ओके. Now let's try to go for one problem. ठीक है. So what is this problem? This is very simple. A phase shift is 30 degree. ये phase shift कितना है 30 degree है, and this is only S wave यहाँ पर excited है. S wave excited है तो इसका क्या मतलब है, L is equal to 0. So delta 0 is 30 degree and energy कितनी है, energy दिया हुआ है 0.1 mega electron volt. So you have to calculate if delta naught is 60 degree, what will be your energy? And it is also given the total scattering cross section is not going to change. Total scattering cross section नहीं change होता है. You have to use this formula, isn't it?
yes sir.
Yes, sir.
क्या हो जाएगा बताओ, sigma is equal to 4 pi k square, that means what, 2m e upon
Yes,
h cut
sir.
square, k square तो यही होगा, और L is equal to 0 दिया हुआ है, तो क्या हो जाएगा, that is what, E1 कर देते हैं, and delta नॉट की वैल्यू क्या है, that is 30 degree. Yes, must be equal to 4 pi upon 2m E2 upon h cut square, and this is your sine square, na? Sine square 60 degree. You can easily get what is value of E2.
Sir,
निकाल लीजिए, कितना आ रहा है
0.3 मेगा इलेक्ट्रॉन वोल्ट.
0.3 मेगा इलेक्ट्रॉन वोल्ट. सही है ये, just check it. Everyone is comfortable? So now you can see how simplest problem is this. Now let us go for one more problem. सिर्फ फॉर्मूला याद रहेगा तो आप इजिली उसे कर पाओगे. Again for L is equal to 0 state is there. L is equal to 0 state is there, and delta naught is 90 degree. Okay, delta naught is 90 degree. The K wave vector is given √2 pi Fermi meter inverse. Then what will be your total scattering cross section? निकल जाएगा ये, बताओ यस या नो.
yes sir.
क्या हो जाएगा, सो सिग्मा इज नथिंग बट व्हाट 4 पाई अपॉन k स्क्वायर. k की वैल्यू दी हुई है, साइन 90 की वैल्यू क्या होगी, दैट इज 1. यू कैन इजिली कैलकुलेट इट. हो जाएगा ये.
Yes, sir.
Okay, so this is again very simple problem. Okay. One problem was very interesting and I wish कि आप लोग इसे solve करो खुद ही. मैंने तो solve किया है and I will also give you solution, but you have to just solve this particular thing. What is given? The differential scattering cross section is given as in form of d sigma upon d cos theta. तो इसे डरने की जरूरत नहीं है. It is given as summation over 2l plus 1 e to the power I delta l sin delta l and pl cos theta mod square. Okay. So this is given, and it is also given that only S and P wave are active. S and P wave are active. It is also given that delta 1 is equal to delta naught by 2. ये आपका दिया हुआ है, ये सारे इंफॉर्मेशन दिए हुए हैं. So what you have to do, you have to calculate the value of cos theta for which d theta is minimum. You have to calculate the cos theta for which d theta is minimum. So now how you will approach it? कैसे approach करोगे? So you have to open this mod square, isn't it? अब
Yes,
जैसे
sir.
ही ये mod square open करोगे, सिंगल समेशन होगा या फिर डबल समेशन होगा?
सर डबल समेशन तो
डबल समेशन होगा, है ना?
सर
क्योंकि दोनों के लिए S और P दोनों में से कुछ भी हो सकता है. So I think your d theta is L1 मैं ले रहा हूं. So d theta is अभी तुरंत किया था ना? That is f star theta and f theta. इसको मैं L ले रहा हूं और इसको L1 और इसके लिए L2 ले रहा हूं. तो व्हाट इज योर d थीटा? डबल समेशन, एक L1 के लिए, दूसरा L2 के लिए. क्या होगा? 2L1 प्लस 1 2L2 प्लस 1. ये क्या हो जाएगा? e टू द पावर माइनस आई डेल्टा L1 e टू द पावर आई डेल्टा L2. यहां माइनस क्यों किया?
कॉम्प्लेक्स कॉन्जुगेट से.
कॉम्प्लेक्स कॉन्जुगेट है, एक को L1 एक को L2 ले रहा है. एंड you have sine delta L1 and you have another thing is sine delta L2. फिर क्या होगा? P L1 cos theta. फिर क्या होगा? P L2 cos theta. इसे ओपन करना पड़ेगा. Yes? Are you getting my point or not?
Yes, sir.
है ना? इसे जब ओपन करोगे तो L1 की वैल्यू क्या क्या पुट करोगे? 0 और 1. L2 की वैल्यू क्या पुट करोगे? 0 and 1. And once you will open it and you will put all this condition, then you have one particular d theta का आप एक फंक्शन लिखोगे. किसके टर्म में लिखोगे फंक्शन? You will just write the function d theta. क्लियर है? ये हो जाएगा ये,
Yes, sir.
है ना? जस्ट ट्राई टू डू दिस थिंग. मैंने कर रखा है, मैं आपको सॉल्यूशन दे दूंगा. Don't worry.
तो आएगा सर.
cos थीटा तो आएगा ही. क्या हल्ला कर रहे हो? हाँ
हाँ सर, ठीक है ठीक है ठीक है.
अरे पीएल कहाँ जाएगा, है ना? सो आई एम जस्ट गिविंग यू द फाइनल ऑफ द डी थीटा. ये मैंने कर रखा है, आप करोगे इसे. मैं इसका आपको वीडियो भी शेयर कर दूंगा, सो डोंट वरी. सो दैट वैल्यू इज साइन स्क्वायर डेल्टा नॉट प्लस 9 साइन स्क्वायर डेल्टा नॉट बाई 2 एंड यू हैव कॉस स्क्वायर थीटा प्लस 3 sin delta naught at sin square delta naught cos theta. This is your d theta as a function of cos theta. अब मिनिमम के लिए आप क्या करोगे? You will just go for dd upon d theta is equal to what? 0. और यहां से आपका cos theta की वैल्यू आ जाएगा -2/3 and that value is equal to cos square delta naught और -2/3 cos square delta 1/2. sorry, delta naught by 2, and so that is cos square delta 1. अब आपका काम क्या है? आपका काम ये है कि आप यहां से यहां पर आओ. जस्ट यू कैन यूज लिटिल बिट ऑफ योर ब्रेन. ब्रेन क्या यूज करना है? 4 टर्म मिलेंगे आपको. पहला टर्म क्या होगा? 0 0. दूसरा टर्म 1 1 0 1 1 0. उससे टर्म 4 टर्म मिलेंगे एंड येट फाइनली यू कैन राइट इन दिस फॉर्म. और फिर उसके बाद आप इसे सॉल्व कर सकते हो. ओके, तो दिस इज वन ऑफ द वेरी नाइस प्रॉब्लम केम इनटू योर एग्जाम. सो आप इसे एक बार जरूर सॉल्व कर लो. क्लियर है ये?
Yes.
है ना? सो दिस इज फ्रॉम माय साइड ऑफ स्कैटरिंग. इतना आप ट्राई करो करने का और फिर देखते हैं इसके आगे क्या कर सकते हैं. ठीक है? सो कल मैं आपका ये टॉपिक खत्म करूंगा, रिलेटिविस्टिक इलेक्ट्रोडायनेमिक्स. जस्ट हाफ एन आवर का टॉपिक है, बहुत ज्यादा कुछ है नहीं. आपको आपने ईएमटी तो कर लिया है ना?
Yes.
तो ईएमटी का ही थोड़ा सा यूज होगा उसमें और लॉरेंस ट्रांसफॉर्मेशन का यूज करेंगे. सो थोड़ा सा लॉरेंस ट्रांसफॉर्मेशन देख लो और फिर उसका आप यूज कर सकते हो. ओके
Okay.
ओके.
सर ये जब स्क्वायर को ओपन करेंगे डी मॉड स्क्वायर को, ऑलवेज सर सामूभर इल अगर है तो दोनों
यस,
इल
दो
होने
पार्ट में ही करोगे. यस, ऑलवेज. ठीक है? आर यू गेटिंग माय पॉइंट?
नहीं आ
Yes,
रहा
sir.
हाँ, समझ में आ रहा है ना?
Yes, sir.
Yes.
तो आपको हमेशा दो पार्ट में ही इसे करना पड़ेगा. ठीक है? सो एक क्वेश्चन और कर सकते हैं. लेट मी जस्ट ट्राई टू गो फॉर वन मोर प्रॉब्लम. देखते हैं उसे, है ना? दिस इज वेरी इंटरेस्टिंग. जस्ट टू फील ऑफ पार्शियल वेव एनालिसिस, उसके लिए जस्ट अ मिनट. सो सपोज एक क्वेश्चन जस्ट मैं आपको थोड़ा सा ग्लिम्स दे देता हूं कि पार्शियल वेव एनालिसिस को कैसे सॉल्व करते हैं, है ना? थोड़ा सा जस्ट ग्लिम्स दे देता हूं. ओके, अगर आएगा तो यही प्रॉब्लम आएगा, अदरवाइज कुछ नहीं आएगा, है ना? सो आप एक बार बुकलेट भी जरूर देख लेना. ठीक है? सो सपोज
Okay.
व्हाट वी हैव वी आर इज इक्वल टू infinity if r is less than a and 0 if r is greater than a. So what you have to do, you have to write the complete the total scattering cross section for low energy. लो एनर्जी के लिए आपको टोटल स्कैटरिंग क्रॉस सेक्शन यूज करना है. कैसा पोटेंशियल है आपका?
नहीं
थ्री
सॉरी
डायमेंशन.
3 डायमेंशनल के रूप में सोचोगे आप, कुछ ऐसा पोटेंशियल है ना? यस, दिस इज ए. और ये कैसा है? रिजिड वॉल है ना? रिजिड बॉल, रिजिड स्फेयर. यस, ऐसा ही तो है.
हाँ सर.
तो यू कैन अप्रोच इन ऑल पॉइंट्स. यहां पर पोटेंशियल क्या है? 0, यहां पर इंफिनिटी. सो इफ r इज लेस देन 0, व्हाट इज योर वेव फंक्शन? रेडियल पार्ट की बात करते हैं. व्हाट इज योर वेव फंक्शन? या ur की ही बात करते हैं. क्या होगा वेव फंक्शन आपका? 0 नहीं,
ये सब 0 होगा.
सॉरी, r इज लेस देन a. ये a
हाँ,
पॉइंट
लेस
है,
देन
यहां पर क्या होगा? 0.
जीरो.
यस, एंड ur इज इक्वल टू a. एंड इस रीजन में वेव फंक्शन क्या है?
साइन
स्कैटर्ड वेव फंक्शन. यस,
Yes, sir.
कैसा होगा ये? a साइन
Sin
के आर प्लस डेल्टा. यस,
Yes.
क्योंकि यहां पर कैसा वेव फंक्शन होगा? टोटल वेव फंक्शन एंड स्कैटर्ड वेव फंक्शन. तो डेल्टा एल के साथ ही तो होगा ये.
ये सब
Yes, sir. Yes.
e टू द पावर आई के आर प्लस डेल्टा एल माइनस e टू द पावर माइनस के आर प्लस डेल्टा. ऐसा ही होगा कुछ. यस या नो?
Yes, sir.
एंड नाउ
Yes,
व्हाट
sir.
यू हैव, you can easily have a boundary condition. So boundary condition से क्या आ जाएगा?
सर ए इक्वल
साइन के आर प्लस डेल्टा एल is equal to what? 0. So KR plus delta and R is equal to what? A. और लो एनर्जी के लिए डेल्टा नॉट की वैल्यू क्या हो जाएगी? दैट वैल्यू इज ऑल्सो लो एनर्जी मीन्स व्हाट? ओनली लोअर वैल्यू ऑफ wave or partial wave are excited. Are you getting my point?
Yes,
So
sir.
only delta naught is there. So this value is equal to delta naught की वैल्यू क्या हो जाएगी? Minus K. I have to just go for delta naught. I can just go for K. What is your total scattering cross section? Summation over क्या होता है? 4 pi upon K square 2L plus 1 sin square डेल्टा L. लेकिन हम यहाँ L इज इक्वल टू 0 के लिए ही कर रहे हैं. सो व्हाट इज दिस पर्टिकुलर थिंग? बताइए. 4 pi K square and this value is sin square KA. यही होगा ना? And for the low value of energy, we can write Ka whole square into Ka whole square. This value we can take 1. So this and this will cancel out. So what do you have? 4 pi A square, isn't it? And this will match with the actual result. Classical scattering क्या आ रहा था? Pi A square. Remember? याद है?
Yes,
Yes, sir.
Pi A square. Low value of energy क्या आएगा? That value is equal to 4 pi A square. And high value of energy आप देखोगे, that value is 2 pi A square. हाई वैल्यू ऑफ एनर्जी के लिए क्या होगा? ऑल पॉसिबल एल इज एक्साइटेड. ये सारा का सारा एल आपका एक्साइटेड होगा. तो एल की वैल्यू कहां से कहां जाएगा? 0 टू एट n-1 है ना? तो दैट विल बी n-1 एंड दैट विल बी एल मैक्सिमम तक आप जाओगे. तो उस कैलकुलेशन में नहीं जा रहा हूं. जस्ट यू कैन यूज दिस रिजल्ट. ऐसे भी आपको याद रखना है, जब हाई एनर्जी होगी तो आपका क्या होगा? पेनिट्रेशन पावर ज्यादा बढ़ जाएगा, है ना? तो सुपर इंपोज होने का, द वेव फंक्शन के सुपर इंपोजिशन का चांस क्या है? बहुत ही कम हो जाता है. लो एनर्जी दे कैन इजिली सुपर इंपोज. सो जो आपका इफेक्टिव सरफेस है, जो पाई ए स्क्वायर क्लासिकली दिख रहा था, वो बहुत ज्यादा दिखाई देगा. आर गेटिंग माई पॉइंट? एंड और ऑब्वियसली क्वांटम मैकेनिकल है तो क्लासिकल से तो ज्यादा होगा ही, बिकॉज देयर आर लिटिल बिट ऑफ सुपर इंपोजिशन. जितना ज्यादा सुपर इंपोजिशन होगा उतना ज्यादा आपका सरफेस एरिया दिखाई देगा. यस? ठीक है. सो यू कैन जस्ट यूज ऑल दिस थिंग. इसको एक बार देख लेना एंड जस्ट ट्राई टू लुक एट योर बुकलेट. एक बार अपना बुकलेट जरूर देख लीजिएगा. ठीक है?
ओके सर.
ओके. सो आज के लिए इतना ही रहने देते हैं. कल 45 मिनट या 1 घंटे की एक क्लास लेंगे, तो जिसमें आपका चीजें करंट डेंसिटी और इलेक्ट्रिक फील्ड, मैग्नेटिक फील्ड के बीच का रिलेशनशिप, उसके थ्रू हम चीजों को इजिली फिनिश कर पाएंगे. ओके?
यस सर.
ओके. चलो, थैंक यू.
थैंक यू सर.